Great pleasure to have Professor Bradley here.
Oh,
Microphone.
is this good?
Yeah.
It is my pleasure and yours to have Professor Raymond Bradley here. He is a distinguished research professor in the Department of Earth, Geographic and Climate Sciences, School of Earth and Sustainability at the University of Massachusetts. Professor Bradley has carried out extensive field work in the Arctic and North Atlantic region. He has received honorary degrees from several universities around the globe, and he has received the Zuckerberg Leadership Chair, the Zuckerberg Leadership Award from the University of Massachusetts Foundation. Professor Bradley has written or edited 13 books on climate change and authored or co-authored more than 220 peer-reviewed articles on the topic. So let's welcome Professor Raymond Bradley.
Thank you very much. I'll take my coat off. We're not talking about global warming after all. So I called the title of this book "The New Normal" because we often hear on the TV people describing some event, and they'll say, this is the new normal, which in fact it is. So before we start, I'd just like to ask you, what do you think of when we use the term normal? What does that mean to you? What is normal? How would you use another word to describe it?
Average.
Sorry?
Average.
Average, yes, for sure.
Usual.
Sorry?
Usual.
Typical, yeah. Anything else?
What we're used to.
What we're used to, exactly. Any other suggestions? So if you look it up in the dictionary, normal, you get something like this. Standard, regular, ordinary, we mentioned, average, habitual, natural. Well, natural, that's a bit controversial, but anyway. Those are the kind of things that we think of when we talk about normal. I like to think of it this way, that going forward for some reason. Sorry. Yes, climate is what we've come to expect. It's what we've based on our experience, right? So we all have experience. If you were describing to somebody from Australia, if they asked you what's the climate of New England like, you describe it based on your own experiences. And similarly, they might tell you what it was like in Australia. But things are changing. And what we're experiencing now is not what we have got used to. And that's the result of this phenomenon that we refer to as global warming. So what I'm going to do is explore what we mean by global warming and what the consequences have been and are likely to be. So this is simply a graph that captures global warming. This is the global temperatures going from 1880 to 2020. And the base period here is 1951 to 1980. So we start off with that reference. Everything is expressed relative to that 30-year period. But normally we express climate in terms of 30-year averages. And you can see the black dots are the year-to-year variations, the red lines, the smooth line. Temperatures have been rising persistently, especially over the last 40 or 50 years. And you can see what we experienced in the last decade or so are exceptionally warm temperatures that have exceeded anything we've had globally over the last 100 years or so. And 2023 is no exception. In fact, 2023 will be above any point on this graph, for sure. Seems to be a bit of a delay. Now, that was the global average, but if we look at the geographical pattern of warming, You can see it's not equally distributed across the globe. And in fact, the red colors here obviously indicate the more warm conditions. And these are the 3 years, 2021, 2020, 2021, 2022. And you can see that the maximum warming is happening at high latitudes in the northern hemisphere, in the Arctic. And that's as a consequence of, among other things, the loss of snow and ice, which is a very reflective surface, keeps the area cooler. For every 1 or 2 degrees of warming globally, the average, the Arctic is warming 2 to 3 times that. So if the globe warms 1 degree or 2 degrees, the Arctic is warming 3 to 6 degrees Celsius. That's getting on to 10 degrees Fahrenheit. So much different conditions in different parts of the world. We refer to this as polar amplification. Just to bring you up to date, these are the 2 maps for 2023 so far. This is the spring at the top and the summer conditions globally. And you can see again, most of the globe, well, almost everywhere on Earth is getting warmer, but it's particularly been warm again in the Arctic, especially in the spring conditions when the snow has disappeared. And the other point about this is it's not just warming on the land or in the atmosphere, it's also warming the oceans. And this graph shows the amount of heat that's being sequestered in the upper 2,000 meters of the ocean. So the ocean is mixing, unlike the land, which doesn't mix. So any warming in the atmosphere is being translated and moved down into the body of the ocean. So the upper part of the ocean is warming over time. And we can see this has been a steady increase. This goes back to 1960. You can see we're steadily accumulating heat in the ocean. And that's important because if we ever stop warming the atmosphere, there'd still be heat in the ocean that would leak back up into the, to continue warming the atmosphere. Now, what's happening in terms of global warming is these temperatures are being driven by the increase in the greenhouse gases in the atmosphere, or greenhouse gases, the principal one of which is carbon dioxide. This is a photograph of a monitoring station on the Big Island of Hawaii, up around 11,000 feet. It's operated by NOAA, the National Oceanic and Atmospheric Administration, Mauna Loa, and they've been measuring carbon dioxide in the atmosphere since 1957 at this site. And they've selected this site because it's in a very remote part of the world. It's not affected by air pollution or urban effects at all. It's sensing the general conditions across the Pacific Ocean. And if we look at the measurements that have been made there since 1957, this is what it looks like. And what you see is the zigzag going up, steadily rising from 1957 to the present. And so ask yourself, what is that graph telling us? There are 2 things, this up and down variation, and then the long-term trend, which is pushing the zigzag up into higher levels. If we zoom in on a part of that curve, here's the zigzag that we see. What does that represent? That is telling us, that is capturing the breathing of the biosphere, of the plants all around the planet. So in the spring, when in the northern hemisphere, particularly in the deciduous areas, the plants come into leaf and they draw carbon dioxide out of the atmosphere in the process of photosynthesis. And they fix the carbon dioxide into tissues, into leaves and wood, extracting it from the atmosphere. And as a result, the carbon dioxide levels go down. In the fall, when the leaves fall off the trees and the growth ceases and the carbon dioxide goes back up again. So what this graph shows us is the literally the breathing in and out of the biosphere as it takes carbon dioxide out of the atmosphere, and then it goes back into the atmosphere when those tissues get oxidized. So that's one explanation. But then the underlying question is, what is this black line? What is the trend that we saw? That is the burning of fossil fuel, the result of fossil fuel burning. What is fossil fuel? You think about coal. Coal is based on plant material and wood that 200 million years ago extracted carbon dioxide from the atmosphere. Just as the same process that happens today. That carbon dioxide was taken out of the atmosphere, and then over geological time, those plants and woody material got compressed and turned into coal. Similarly, organisms living in the ocean were eating plant material, and they died and got compressed, and they produced oil and gas. So today we're extracting that fossil fuel that was involved in the same processes that we see today, and we're burning it and putting carbon dioxide back into the atmosphere at a phenomenally faster rate than that CO2, that carbon dioxide, was removed from the atmosphere hundreds of millions of years ago. So then we see this rising level of carbon dioxide, which was measured since 1957, until today it's gone up to 420 parts per million in the atmosphere. Now, the question is, well, what happened before 1957? How do we know this is not just some little blip that took place? Well, fortunately, we have a way of figuring that out. But let me just say, before I talk about that, it doesn't matter where you are in the world. You could be in the middle of the Pacific on Hawaii. You could be at the South Pole, or you could be at the North Pole, and you would see the same thing. You'd see the up and down variations from year to year, season to season, and you'd see this background trend. And that's because the atmosphere is mixed very quickly. So even though the pollution that or the fossil fuel that we burn may be taking place in the northern hemisphere, you can sense that, you can see it, even at the South Pole, where nobody's burning coal down there. So this is a global impact when we take fossil fuel and we consume it. But how do we know what the long-term trend has been? Fortunately, we have this unique resource in polar regions. We can go to Antarctica and Greenland, to the ice sheets there, and we can drill down through the ice sheet. What happens in the very coldest parts of Antarctica, we have snow falling every year and accumulating and getting compressed by the following year's snow. And it builds up. It doesn't melt because it's too cold. So as that snow gets compressed year by year by year and get buried by snow that's falling afterwards, basically if we drill down through the ice sheet, we're going back in time. So we have a measure of what the atmosphere was like year by year going back in time. And in Antarctica, we can drill down all the way to the bottom of the ice sheet, and that takes us back almost 1 million years. Now, as the snow accumulated, within the crystals of snow, we get little bubbles of gas that get captured in the ice as the snow is compressed into ice. So we can go down to take those ice cores and extract from the bubbles what the carbon dioxide levels were like going back in time. It gives us a time history, like a library of what the atmosphere was like in the past. I said we can do that for 800,000 years, but I just want to show you for the last 2,000 years what it looks like. So here we got a graph showing going back 2,000 years, so this is the time of birth of Christ to the present. And what you see is, this is the level of carbon dioxide in the atmosphere. It almost never varied. It was almost within experimental era, pretty flat for 2,000 years, almost 2,000 years, at around 280 parts per million. That's the measurement in the atmosphere. And then something happened. You can guess what happened. We had the Industrial Revolution. Scott invented the steam piston engine in 1784, and that required coal to heat water to make steam to move pistons that created power at the beginning of the Industrial Revolution. And somebody had the bright idea, well, why don't we put that on wheels? And then they made locomotives. And then about 100 years later, Mr. Benz and Mr. Daimler invented the internal combustion engine for cars, and that shifted the demand towards oil, or oil products, petroleum products. So over the course of a century or so, we went from producing or using more and more coal and more oil for industrial and transportation and heating processes. And as a result of that, you can see exactly what happened to the levels of carbon dioxide in the atmosphere. They have gone from 280 to 420 parts per million. In other words, they've gone up 50%, way above anything that was experienced for the previous 1,000 years. In fact, we can go back 10,000 years, and it's the same. It's 280, more or less, parts per million, and it's been that way for a long time. Suddenly it's gone up, and that's because of human activity, and that is driving global warming. How do we know? So carbon dioxide has a unique feature. It is transparent to incoming energy from the sun, incoming radiation. That means the energy can pass through the atmosphere without heating it. But when that energy is absorbed at the surface of the Earth then radiates energy back at a longer wavelength, a different wavelength. And the carbon dioxide is very sensitive to that longer wavelength, and it traps the energy coming from the Earth. We always think of the Earth as being heated by the sun, but in fact, the atmosphere is heated from the bottom. That's why when we go up in altitude, up in the mountains, it gets colder. We are heated from below by the energy that comes from the sun and warms the surface of the Earth. So when we put more and more carbon dioxide into the atmosphere, it's like having a blanket or an extra duvet on your bed. You're trapping more and more of the energy that would otherwise escape from the surface into the atmosphere. So as we add more carbon dioxide into the atmosphere, we're making the trapping mechanism more efficient, and that's warming the Earth system. Now it's a lot more complicated than that, of course. This is a simple diagram. For example, 70% of the Earth is ocean. So when we warm the atmosphere, we create more evaporation. More evaporation leads to more water vapor in the atmosphere. And water vapor is also a greenhouse gas, what we call a greenhouse gas, like carbon dioxide. So we amplify the carbon dioxide system because we're putting more energy into the atmosphere, more water vapor. And the flip side of that is we get more clouds. And the clouds tend to shield the Earth from incoming energy. So it's a complicated system, but we can put all that into computer models and we understand how that works. And the overall effect, when you take all that into account, is that carbon dioxide and water vapor are causing the Earth to warm, and they're putting more energy into the atmosphere, which makes the atmospheric processes, the weather, more and more energetic, more and more potentially severe, as we'll see in a minute. Now, as I mentioned, we can demonstrate that with computer models. We have very sophisticated computer models. These are basically very complex weather forecasting models. same processes. They model the physics of the atmosphere. And we can take all of the variations that we know affect the climate. And those are the natural factors, would be volcanic eruptions, which tend to cool off the Earth, changes in solar activity, sunspot cycles and so on, natural changes in dustiness from the Sahara Desert and so on. We can put all those things into the model, and we can run the model for 100 years. And we can ask ourselves, how well does the model capture or mirror the observed temperatures? Right? The first graph I showed you was the rising temperatures that we've measured around the world. And that's this black line here. So the question is, how well does the model mimic what we know happened? And the answer is, it doesn't do very well at all if you only put into the model the natural factors. So the only way we can get the model to mimic what we observed is if we put into the model not just the natural factors, but also the carbon dioxide and other greenhouse gases. Then you can see the model mirrors the observed extremely well. This is a very good experiment to demonstrate the effect of carbon dioxide. We could show that without carbon dioxide, temperatures would not have risen to the extent that they have. It would be essentially flat. Now, over the years, there has been a periodic review by the world scientists, climate scientists, and it's called the Intergovernmental Panel on Climate Change. You may have heard about this, IPCC. That every 4 or 5 years, there's been an IPCC report going back into the 1990s, and eventually the IPCC was awarded the Nobel Peace Prize along with Al Gore a decade ago. I was part of this IPCC report in the early days, and so every now and again people introduce me and say, "Oh, Ray Bradley got the Nobel Peace Prize." No, not really. I wrote a little tiny part of this. But anyway, this is the conclusion that the IPCC report came to in the latest report, 2022. Unequivocal, no question now. Human activity has influenced, has warmed the atmosphere, the oceans, and the land. With widespread changes in the atmosphere, the oceans, the cryosphere, which is the realm of snow and ice and glaciers, and the biosphere, and the plants and animals and ecosystems, both in the land and in the ocean. Furthermore, these changes are unprecedented for many centuries, maybe even thousands of years. And if this warming continues, it's projected that the global water cycle, that is the cycle of rainfall and droughts, will be intensified and we'll get more and more intense rainfall and more extreme weather conditions, both wet and dry. So, it's clear that the global warming has consequences, not just on the natural Earth systems, but also on our infrastructure, our human constructions, and obviously on people around the world, particularly those who are vulnerable around the world. Let me just give you a few examples of that. This is a graph looking down on the North Pole, or a map rather, at the top, showing the extent of ice on the Arctic Ocean in 1979, 2007, and 2020. And you can see that it's been shrinking over time, becoming more open water over the Arctic Ocean, and that of course means there's less reflection of the sunlight coming in, and that's one of the reasons why polar regions are warming faster than other parts of the globe. This graph shows the volume of ice on the Arctic Ocean. So that's not just the area, but also the thickness. Going back to 1980, and you can see there's just been a steady decline over time. That has lots of implications for not just marine mammals, that we often see pictures of a poor polar bear sitting on a tiny bit of ice, but it also has implications for other marine mammals like whales and seals, on fisheries, and on transportation, because as the Arctic Ocean becomes more open, it means more ships can travel from Japan, let's say, across the Arctic Ocean to Europe, instead of going all the way around South Africa to get to Europe. And of course, that also has national defense implications, because suddenly there may be open water between Russia and Canada and the United States. On the other end of the globe, this is Antarctic ice cover. Antarctica is a huge continent. We don't think about it very much. Antarctica is the size of the United States. And every year, the ice around Antarctica literally doubles the size of the continent. You can imagine that. And these blue lines here show the year-to-year variations over the course of a year, from January 1 to December 31st on the x-axis. And you can see it's varied year by year, and a lot of variability. But look what's happened this year, 2023. Suddenly, there's been a huge drop in the area of ice around Antarctica. We don't really understand why that is happening, but it appears to be, if it continues like this, we pass some sort of tipping point or some sort of threshold that means that the ice cover around Antarctica is changing dramatically, and that will have implications all around the world as the ocean currents respond to those changes. One or two more examples from the cryosphere, the snow and ice. This is Glacier National Park. Some of you may have visited it. It may be too late to see the glaciers in many parts of this, because these glaciers are disappearing. This is the Grinnell Glacier in 1938, and you can see in 2013 it's almost gone. And you can see that the formation of a lake where the ice used to be. This is happening in many mountain areas of the world. These lakes are forming. They're often dammed up by a very unstable moraine, a pile of rocks. And occasionally there's an earthquake or a landslide into that lake, and all the water gets blown down the valley and it wipes out villages. It's happened all through the Himalayas. It's happened in South America. Happened in many parts of the world. So these are dangerous conditions that are being created in mountain regions. This is the Chacotaya Glacier in Bolivia. We tend to think of the tropics as not having glaciers, but this one, the subtropics of Bolivia, they're high mountain glaciers. This one was important because it was the water supply for the city of La Paz. 1940 all the way through to just recently, you can see that this glacier has almost completely disappeared, forcing the city to find other water resources. Again, this is just a snapshot of what's happening in different parts of the world. Even in countries as prosperous as Switzerland, they're losing water resources, and they rely on those water resources for hydroelectric power in some places. So what happens to this water? Where does it go? Some of it, of course, goes into the atmosphere, but a lot of times these glaciers feed streams and rivers, and they eventually transfer that water from the glaciers into the oceans. And then that means sea level is going up. And this takes us back to 1700, where this is sea level rise to the present, and then this is projected into the rest of the century if we continue to burn fossil fuels. Sea level's gone up about a little over a foot over this period already. Projected that it may rise anywhere from 1 to 3 feet in the rest of this century, depending on how we manage our fossil fuel use or how much we turn to renewables. Very sensitive to the question of the instability of the West Antarctic ice sheet, which is very uncertain, and the melting of the Greenland ice sheet. We can talk more about that. But clearly, sea level is, if there's one consequence I'm very confident about in terms of future, it's sea level rise. It is going up. It's definitely rising in most of the world, and it will continue to rise. But it's already having consequences, as we see, and many of you may have experienced this too. This is in Miami on a bright sunny day, and this is what is referred to as nuisance flooding. The sea level is rising, the tides are rising, and the water is coming up the sewers, up the drainage pipes, instead of going the other way. I was in Grenada recently in the Caribbean, in the town of Georgetown, and I stood in the main street over a grid in the road, and I literally watched the water come up and go down, up and go down, and that was the tide. That's how close the road was and the city, the main town, was to the present day sea level. And it's already having an effect. There was a tunnel just off the main street and it was flooded. You drove through the tunnel and you went through 6 or 8 inches of water, which wasn't able to drain because it's too close to sea level. So these things are happening already. Now the IPCC report already pointed this out. It said we're going to have, you can see what I've highlighted here, an increase in extremes such as heat waves, heavy precipitation, droughts, stronger cyclones, more frequent events, even fire weather, and complex compound flooding. So this was clearly stated. Nobody should be surprised that these things are going to happen, have already happened, as we saw just in the last year. And in the United States, this shows the number of $1 billion disasters over time. You know, when something happens as a flood or a fire or a hurricane, the governors of the states ask the federal government to declare it a disaster and makes available funding for relief. And you can see clearly the number of disasters has been going up. The costs have now reached hundreds of billions of dollars, literally hundreds of billions of dollars. Who's paying for that? All the citizens of Loomis here and everybody else. The taxpayers are footing the bill for these billion-dollar disasters. So when we talk about mitigation and measures to reduce the impact of climate change, we have to remember we're already paying a huge amount of money for the consequences of these changes. So yes, it costs money to fix the problem, but it's costing us a lot more money if we don't fix the problem. And economists have pointed that out for many years. So we're already seeing a whole sequence of things. This was a flood in Pakistan last year. It affected literally tens of millions of people were displaced. And yet, just further around in China, we had one of the most severe droughts that this country has ever experienced. This is Chongqing, a gigantic city, 25 million people in the middle of the country on the Yangtze River. It's a shipping port in the center of the country. Used to be able to take a big ship all the way from San Francisco to Chongqing. You can see the river almost dried up last year. And of course, in North America, we've had fires all across the northern forests of Canada and elsewhere in the western United States. So far, not in New England, but it happened here. And a lot of people who didn't think they would ever be affected by any of these disasters suddenly found themselves suffering from severe air pollution from something that was happening 1,000 miles away. Air pollution and these disasters very often are not constrained by national borders. What about hurricanes? Will there be more and stronger typhoons or hurricanes with global warming? Almost certainly, because the power of hurricanes is derived from the temperature of the ocean. And as I showed earlier, the temperature of the oceans are rising. This is a map of sea surface temperatures yesterday across the globe. This red patch here in higher temperatures is the El Nino that everybody's been talking about in the Pacific Ocean. It's having an effect on global temperatures. It makes northern parts of the United States quite warm. But what I want to turn your attention to more specifically is what's happening in the Atlantic, the tropical Atlantic. And you can see between Africa and the Caribbean and the Gulf of Mexico, sea surface temperatures are also exceptionally warm, and they have been now for a long time. And this is where the hurricanes develop off the coast of Africa, and they move across and they enter the Caribbean, or they move up the eastern United States. So the strength of those hurricanes is driven by the temperature of the ocean across which those hurricanes develop. So there may not be any more hurricanes, but when they develop, they are likely to be more severe. And we've already seen some of the consequences of that. This was Hurricane Idalia, just in August this year. A 12-foot storm surge driven by the power of the hurricane into the Gulf of Mexico and the western part of Florida. Imagine 12 feet, it's almost the height of this room, flooding the whole coastal region. And this is an interesting statistic. $3 to $5 billion of losses that were insured. 40% of the losses were uninsured. A lot of people didn't have insurance. And so this is when, agencies are asked to step in and help out, but there's only so much you can do. Now imagine this happening in other parts of the world, Pakistan, almost all parts of Africa. People don't have insurance. We're in a unique situation in the Western world. We have insurance, or the opportunity to have insurance. In many parts of the world, Bangladesh and elsewhere, they don't have insurance. So you have a storm like this, that's it, they're wiped out. And unfortunately, this is what's happening. A lot of the consequences of global warming are asymmetrically more severe in the poorer parts of the world. Okay, so what's happening? The governments of the world are beginning to recognize the problem. And a few years ago, 2015, there was great jubilation in Paris. They had this so-called COP, Conference of the Parties, COP21. Think about that in a minute, I'll come back to that, COP21. And they agreed they're going to limit, or try to limit, temperatures so they will not rise more than 2 degrees globally, 2 degrees Celsius, that's 3.6 Fahrenheit, above the pre-industrial level, the level before the internal combustion engine and the steam piston engine were invented, before that carbon dioxide took a big rise. Now, each country was asked to come up with a plan, voluntary plan, and said, this is what we're going to do to make sure we reduce our fossil fuel use, and we're going to contribute to keeping the temperatures lower. Now, if you calculate, you take all those plans, and you figure out what would the result of those plans be? This is what it looks like. So here's the temperatures that we saw has been rising. And the idea is we're going to keep the temperatures below 2 degrees warmer. That is 2 degrees above where we were in the 19th century. But when you read all the reports and you calculate what those reports aspire to, you cannot get to 2 degrees C. Those reports will allow temperatures to rise above 3 degrees Celsius. That's 4.5 Fahrenheit. Now remember, I said at the beginning, when the global temperatures rise by 1 degree, in the Arctic it goes 2 or 3 times that. So we're talking about an Arctic warming of as much as 15 degrees Fahrenheit. This is just catastrophic for those parts of the world. So, okay, that was COP21, Conference of the Party 21. A few years later, there was another COP in Glasgow. It's Scotland. And the parties came back and said, look, this isn't working, we have to do something. So they said, okay, we'll crank it down. We'll raise our ambitions. We'll try to lower the temperatures. And a lot of the small island states that are very close to sea level said, even 2 degrees is too much. We have to get it down to 1.5 degrees. Otherwise, sea level will rise and we'll be flooded out. We won't have any country left. So, so the question is, what do we have to do in order to keep temperatures down to 1.5 degrees? Let me just explain this complicated graph here. On this axis, it shows how much carbon dioxide we've already put into the atmosphere. Don't worry about the units. This is gigatons of carbon dioxide. We'll just look at the number. Let's call it 2,500. So we've already put 2,500 units of carbon dioxide into the atmosphere. And the result of that, on this axis, is the rise in temperature. And you can see it's almost a straight line. So if we want to keep temperatures below 1.5 or 2 degrees, and we project that line forward, then we can say, okay, how much more carbon dioxide are we committed to add to this 2,500? If we keep going, temperatures will rise even more. So we know where that limit is to keep it to 2 degrees. We just go across and we come down. And what does that look like? Oops, wrong way. So here's that 2,500 or more or less. If we want to keep temperatures below 1.5 degrees of warming, we can only add another 380 units. If we want to keep it below 2 degrees Celsius of warming, we can only add another 1,230 units, okay? Gigatons of carbon dioxide. What does that translate to in terms of what we're doing? Right now, this is the emissions by country. You can see the United States and Europe, and here's China's just taken off recently. The total of all of these countries is about 40 units, 40 per year currently, 40 per year. But think about that. Go back to this graph. 40 per year is what we're producing. So if we want to keep temperatures to this threshold, 1.5 degrees, we've only got 9 years left. If we keep burning at the current rate, within 30 years, we'll have used up the bank balance, if you like, of what we're allowed to burn if we don't want to keep the warming below 2 degrees. So, obviously, if we lower emissions, so it's not 40 per year, but 20 per year or 10 per year, it gives us longer, it extends the time before we're going to reach that threshold. So that's the key. We have to lower emissions. And the last graph I'll show is this one. This shows what happens if we suddenly stopped. If we stopped tomorrow all the carbon dioxide going into the atmosphere. Would the carbon dioxide disappear? No. Within a century, it'd still be 1/3 of all the carbon dioxide staying in the atmosphere. And that's because the processes by which carbon dioxide are removed, the photosynthesis and so on, is very, very slow. It takes a long time to catch up. And that's why even if we stop emitting carbon dioxide tomorrow, this problem of global warming is going to persist into the future, indefinitely. And that's why I say we're in the new normal. It's not going to go away soon. That doesn't mean we shouldn't reduce emissions. Of course we should and we must. But We shouldn't think that that's suddenly going to fix the problem and we're going to go back to the old normal. That's not going to happen. So, climate change is not going to go away anytime soon. We're in a new normal, but I love this graph. People are engaging, they're demanding action, they won't give up, they won't give in. And that has made a huge difference. Young people especially, marching, protesting, and people like you who are asking policymakers and politicians, what is your plan? What are you going to do? We can all do things individually, but collectively, on a government level, that is what will make the difference. And so the most important thing anybody can do with their concerns about global warming is to vote for the right people who will do something about it. Now, there has been legislation recently. This so-called Inflation Reduction Act has made an enormous difference in the possibility of enhancing renewables, promoting renewables, reducing fossil fuel, and so on. So that's a positive start. People often say, you know, we can't afford this, it's going to kill the economy. This is clearly not the case. This is from California. Just point out the green line. This is essentially their gross domestic product, their economy since 2000. It's been going up and up and up, just as the population has risen in the state, and yet they've reduced the greenhouse gas emissions. In fact, the governor claims that the economy has grown because they've reduced emissions, because it's driven new industry, it's driven new innovation, and it's saved consumers money because they're not using as much fossil fuel. And the last point here same thing from Massachusetts. Here's our gross domestic product in green, and here's our greenhouse gas use in purple. So the economy has grown and our emissions have declined. So if the two go together, you can build a stronger economy at the same time as you can reduce emissions. Okay, last point. Today, COP28 is taking place in the United Arab Emirates. I mentioned that Paris was COP21. What does that mean, 21 or 28? There's been 21, or now 28 attempts since the 1990s to come to some international agreement on these issues. Progress is slow, there's no doubt. This one is especially interesting because it's led by Sultan Al Jaber, who is also the head of the biggest oil company in the United Arab Emirates. Now, a lot of people are saying this is crazy to have an oil executive in charge of these negotiations over emissions. I don't have an opinion about this, but I listened to John Kerry, who's our advocate. John Kerry says this is a good thing because if you don't have the foxes involved in the negotiations, then you can never solve the problem. And maybe he's right. Certainly, these guys can put huge amounts of money on the table to help the developing countries avoid using fossil fuel. So for example, if we go back to that Paris agreement, a country like Angola in Africa says, well, half of our people don't have electricity. So we can't just stop developing. We have to develop. We have to improve the standard of living for everybody. But we can only do that if we burn coal because we've got vast coal reserves. And so they say, however, if you can help us, if you can give us $15 billion from your vast resources, we can avoid using coal. We can build hydroelectric power plants, we can build offshore wind, we can build renewables. And then we won't contribute to the greenhouse gas problem. Well, we can't do it on our own. We don't have the resources. So they turn to the richer countries who have contributed most to this problem, North America and Europe in particular, and increasingly China, and they say, we need help. And so part of this COP agreement was to put up $100 billion to help the developing world continue to develop, but to do so without using conventional fossil fuel, to do it by using more and more renewables. And you might say, well, why should we give money to those countries? Because it comes back. It comes back in the negative way because we have more severe weather as the temperatures rise. But let's face it, most of those development projects are using companies that exist either in Western Europe or North America. So it's an economic benefit in a way, just like a lot of foreign aid is to the United States. Okay, so with that I will stop, and I'll just end with this quote from Martin Luther King that Barbara's heard me say before. Because this was said in the context of civil rights, but I think it's very applicable to the current issue. He says, when the issues at hand seem as perplexing as they often do, we're on the verge of being mesmerized by uncertainty. But we have to move on. We're faced with the fact that tomorrow is today. There's this fierce urgency of now. We have to do something now. Can't wait. In this unfolding conundrum of life and history, there's such a thing as being too late. We could cry out desperately for time to pause in their passage, but time is deaf to every plea and rushes on. Over the bleached bones and jumbled residue of numerous civilizations are written the pathetic words, too late. We cannot be too late on this issue. We have to do something. And I think these words ring very profoundly and resonate with the issues that we're facing on the environment today, just as they were in his time for civil rights. Thank you very much. I have the question, yes, sir.
Yeah, I have a two-part question about remediation. I'd be interested in your perspective on the efficacy and the scalability of technologies to extract carbon dioxide from the air, number one. And number two, to seed the upper atmosphere with sulfur dioxide or something equivalent to reduce the solar radiation effect. Do you think that those offer significant hope for us?
No.
Well, that's an honest answer, thank you.
Let me elaborate. I think let's take the first one, which is the idea of extracting carbon dioxide from the atmosphere. In fact, we have to do that. There's no alternative to do that if we're going to avoid this indefinite new normal that I talked about. And in fact, what's very likely to happen with this COP28 meeting is that the big oil countries, Saudi Arabia, UAE, and so on, are going to come out with a statement that, I forgot the exact phrase they used, but the idea is that we can continue to burn fossil fuel as long as we take the carbon dioxide out of the smokestack as we burn it, and we sequester it in the ground. We put it into underground reservoirs or even in the ocean or somewhere, into some solid rock. Now, currently, there are no scaled up technologies, as you put it. There are some demonstration plants, there's one in Iceland, for example, that is using geothermal heat as an energy source in order to take carbon dioxide out of the atmosphere. And it works. But all of the carbon dioxide they're sequestering is equivalent to 13 minutes of annual global emissions. 13 minutes. Now think about that. You'd have to scale up that process massively on a global basis. And you'd have to have some other renewable energy source if it's not geothermal. Iceland's a unique place. So yes, I think that we have to pursue those technologies. We have to try and scale them up. It's not, I mean, you think about how many coal plants there are in the world now, tens of thousands. So maybe, you know, in the future we need tens of thousands of plants that would suck CO2 out of the air. But the technology is still very premature. And Biden administration is putting billions into some demonstration plants, and we'll see how they work out. On the other point, which is to try and reduce the amount of energy coming in from the sun, putting some sort of material in the upper atmosphere. The idea is that we would mimic a big volcanic eruption that happened in the past. The problem of that is it's not a uniform response in the climate system. There are winners and losers in the climate system. So you might cool off the Earth, but you might reduce monsoon rainfall in India, for example. And you just think about the practicality of doing that. Who would control that process? Who would have the authority? Is it Jeff Bezos or Elon Musk, who could certainly afford to fly jets around and spew out sulfur in the atmosphere? Or would it be a country like China or the United States or Russia who would take the authority? Who would oversee that? I just can't see any conceivable way that is going to happen. And I think the consequences of the negative consequences would be catastrophic potentially. So I don't see that's a solution. Yes.
You mentioned the slowness in the uptake of CO2 by plants and the photosynthetic process.
Yeah.
And yet there's great interest today in trying to save particularly mature forests and grow more plants to do this. Do you see that as any viability to help reduce this particular problem?
I think it's an essential part of the solution, but I don't think it's just to say, to use the term this gentleman used, it's scalable to the point where it would have a big enough impact. I think the biggest benefit of reforestation and preserving forests is biodiversity. And personally, I feel that the biodiversity issue is perhaps even more severe and more problematical than the climate change problem, because they're intertwined. But you know, extinctions are forever. Once you've lost species, they're not coming back. And I do think that in the pristine areas that I visited in the tropics, that the whole idea of just cutting down forest and planting soybeans or grass for hamburger meat, I think it's just a tragedy, and it ought to stop.
And when you consider that a lot of the products coming out of the forests are for really specialized purposes, such as toilet paper and so on, you wonder if what we're doing is cutting off our nose to spite our face, because if plants do help, why are we cutting them down in such great numbers?
Yes, I agree, and often for modest gains, and often for the richer developed countries to use. Yes, question?
Is there anything we could be doing here at Loomis, such as heat pumps or solar roofs,
Yes.
that we're not doing?
I don't know what you're doing. I don't know what you're doing, but certainly every organization, you know, recently I just flew over Miami. I couldn't believe it. There's miles and miles and miles of flat top buildings as we were approaching the airport. As far as the eye could see, there were factories and other buildings. Not a solar panel to be seen anywhere on these buildings, and of all places. So, you know, I think we're not being realistic about what we can accomplish. Solar panels now are so cheap that almost giving them away. And they're very efficient. So everybody, when they can, should be doing implementing those things. The government is subsidizing left and right. It's almost no excuse for people not to be looking into that, at least, as to see if it's feasible. Geothermal, of course, for an institution like this would be a fantastic opportunity to use that energy source. Yes.
Are you aware of any organization that's calculated the increase of those units you were talking about, of CO2? How many units have been contributed to the atmosphere by the bombings in Ukraine and Gaza and Palestine?
I can't answer that. I don't know. I suspect it's not very significant in the big scheme of things. Just to add a similar thought to that, the burning of forests across Canada this year contributed a huge amount of carbon dioxide to the atmosphere, all that wood that was consumed. And when we talk about, going back to your question, we talk about reforestation and sequestering carbon dioxide in forests and plants, we have to remember that they occasionally can go the other way. So you might invest a lot, let's say if you're a billionaire and you might say, I'm going to buy a million acres of forest and I'm going to preserve it, and then the next day it burns down because of drought. So, you know, it's not a slam dunk. Yes.
As we imagine how to find new sources of power to supplant carbon-based, what do you think the role of nuclear power will be going forward, and what's the prospect of developing hydrogen power?
I can't answer the second part of hydrogen power. I don't know enough about that. But in terms of nuclear power, I'll just tell you a brief story. I was actually hired several times by a company that was, in its turn, hired by the federal government to investigate high-level radioactive nuclear waste sites and how safe they were. This first one was in Yucca Flats in Nevada. And what they wanted me to evaluate was how stable this location would be for the next million years. And I thought about this and thought, oh my God, why would we do this? Think about our civilization. You know, since the first writing, the first city, we're talking about 5,000 years. And we're producing some radioactive waste that we have to worry about for the next million years, or at least hundreds of thousands of years, and pass that burden on to the next generation. I thought, this is insane. This is completely crazy. So my answer to you is nuclear power, I think, is an excellent source of relatively carbon dioxide-free power. But it has some real downsides. And I don't know of any country or any institution that has solved the problem of what to do with high-level radioactive nuclear waste. And so I would hesitate to endorse that until we have that solution. And just an example too, a lot of times people look to these high-level nuclear waste dumps in remote areas, often occupied by indigenous people who have no voice, are unable to stop it. For example, Finland is building these sites in the northern part of Finland where the Sami reindeer herders are. A lot of times they're in Indian reservations in the United States. The only reason they picked Nevada was because nobody lives there, right? It's not very, especially in Vegas. Nobody would think about building a nuclear waste dump in the Berkshires, right? It would be unthinkable, or in Manhattan. And that's the reason, because nobody wants them.
Hi. Thank you for letting somebody from Apple would say, ask a question. When Biden began to push on this right away, he pushed on methane. And the question was why, and whether that would really buy us thinking time so that we could get better pitch up on some of these issues. What do you think about, besides the fact of trying to ignore permafrost, what do you think about a push for getting rid of methane, otherwise known as natural gas or unnatural gas?
Yeah, so I spent my talk really focused on carbon dioxide, but it's not the only greenhouse gas. Methane, CH4, is also a very important greenhouse gas, and so is nitrous oxide. Methane comes from several sources. One is wetlands, tropical wetlands, natural sources. One is from animals. We've got 1 billion animals on the planet that are all farting and burping up methane. Can you cut that out of the video there? Well, actually, they're mostly burping up methane. And that's solvable because you can modify the diet of animals to reduce methane. But in terms of the methane that you're talking about, Barbara, this is the methane that leaks out of inefficiently used drilling systems. And that is certainly very, very feasible. I'm sure that will come out as a big part of the COP28 negotiations because it's relatively easy to fix. And the big oil companies can take that and wave the flag and say, we're going to do this. And it would have an important impact because methane, it's not as long-lived as carbon dioxide. It dissipates over a decade or two. And so if you can reduce it right away, you would have an immediate impact on the warming. So it's much more efficient at trapping energy than carbon dioxide. So if you can reduce it quickly, you would have quite a big impact and quite quickly. And the nitrous oxide is used in fertilizer, and we can also reduce fertilizer use across the agricultural sector. So there are definitely things we can do in addition to reducing our fossil fuel carbon dioxide emissions. Yes.
I've been noticing that you continuously use the phrase global warming. The chic word for today is climate change, and I assume that they're using the term global warming because that is the basis of climate change.
Well, no. I mean, I think of climate change as any change in climate. I mean, people say to me, oh, you know, don't worry about this. Climate's been changing forever. That's true. That's like, well, duh, that's true. We've had, over millions of years, climate has changed a lot. But those are natural factors. Those are due to changes in the Earth's position in relation to the sun, volcanic eruptions, maybe some changes in solar irradiance and so on. Natural variability of the climate system. That's climate change. But on top of that, we've had what is often referred to as anthropogenic climate change, human-induced climate change, or global warming, the consequences of which is global warming. So global warming is, if you like, it's an add-on to natural climate change. That's the way I think of it. Yes, sir.
The thinking as you're talking about our automobiles, how much of an issue does that contribute to the problem we're discussing?
You mean people who argue that this is not a problem or not happening?
I'm just asking you what you
Yeah.
think.
Oh, I've experienced this a lot. I wrote a book about this, in fact. It's called Global Warming and Political Intimidation. And there have been many politicians who've tried to destroy my career and my reputation by arguing that the research that I've done is false and is fraudulent. In fact, Senator Inhofe from Oklahoma asked the Justice Department to indict me on fraud, along with a bunch of other scientists. There were 17 of us, and he issued a call for the Justice Department to indict us all for using federal research funds to produce research that he considered was fraudulent, because it didn't agree with his views. And I felt proud to be on that list of 17, because the other 16 were really great scientists, so I felt privileged. And thankfully, that was during the Obama administration, and they didn't take him up on his request to indict us. So. But this happens all the time. In fact, there's an organization that's called the Climate Science Legal Defense Fund, led by a lawyer named Lauren Kurtz, who was established as a result of this inquisition that we experienced with Representative Joe Barton in the House of Representatives and others. And they have gone after scientists up and down the country for various so-called crimes, which are not political. They are simply scientific, normal scientific process, but they don't mesh with the political regime. And so the Climate Science Legal Defense Fund is a 501c, volunteer organization, has a bunch of lawyers that will, for free, defend faculty members and government scientists who are being harassed by the legal system. And they've had dozens and dozens and dozens of cases that they've defended people. It's a great organization. Unfortunately, you wouldn't wish that it would have to be there, but it is.
I don't think you answered the question about automobiles and how much they contribute to
Hang on, you want a microphone?
global warming.
I thought the question was, how much do automobiles contribute to global warming?
A lot. In Massachusetts, we have this Global Warming Solution Act that was passed a few years ago, as they did in California, and they have a projection how much they want to reduce emissions, and it's a timeline. You have to reduce emissions so much by 2030, by 2040, by 2050. And the biggest problem, and it almost never changed, is transportation emissions. And I've talked to the various agencies and the governor about this, and the problem is we don't have any sort of logical public transportation system in the state. If you want to go to Boston, there's only one way to get there. That's the Mass Pike. And anybody who's driven on that realizes what an insane system that is. You compare that with Europe, where there are trams and trains, and it's efficient, it's cheap, it's regular, it's high quality. Nobody would think twice about commuting 50 miles into a big city with a car, and then having to find somewhere to park it at $40 a day. I mean, it's just crazy. So, but Massachusetts has not really come to grips with this. I drive an electric car, and coming back from Boston the other day, I was looking, where can I charge the car? Come on. Why don't they have chargers at every single stopping place on the Mass Pike, for example?
Yes.
On Route 2, there's one in Leominster and one in Templeton. There's almost none west of Greenfield going up to Pittsfield. So the government has to get real about this. They have to put they have to require every gas station, for example, to get a license to sell gasoline, you have to have electric car chargers. That would be just simple like that. And they haven't done that yet. So they really haven't come to grips with this transportation problem. You talk about east-west rail, okay, that's a great idea. But you can guarantee, or I can guarantee, that it won't be cheap, it won't be regular, and it won't be widely used because of that. It's not, if you don't have a train every half an hour or every hour, and if it isn't relatively easy to get to and park, so you can get on the train, it won't get used. So the idea that a train system like Amtrak has to be profitable doesn't make sense. We don't ask the highway system to be profitable. We throw money at it. But that's what we have to think about. These transportation systems have to be subsidized. I'm sorry, that's just the way it is. Okay, any more questions? Any more?
Are there any other ways in which you think that our patterns of consumption need to change in order to meet the challenge of global warming?
I'm not going to tell you how to live. Of course, people say, well, we should all be vegetarians, for example. That's a tricky one because if you eat a steak that's grown on some scrubby bit of land in New England that wouldn't be used for anything else, then that's fine. What's problematical are these massive, great feedlots that produce tremendous amounts of methane and use resources that would otherwise, that are problematic. So I think people can modify their life a little bit, even if it just means having one less meal with meat a week or two, because eating meat, generally speaking, involves huge amounts of resources and energy. Certainly, if everybody was driving an electric car, that would help a lot. If people could install solar panels, or your kids could install solar panels where it's feasible, that would also help. Heat pumps, there are millions of ways in which you can, in a modest way, amend your energy consumption. But, having said all of that, what every individual can do is minuscule compared to what the government can do. So the government can amplify your concerns a millionfold just by the stroke of a pen. And that's why whenever I give a talk and people say, what can I do? I say, vote. Vote for, I'm not telling you who to vote for, just vote for the politicians who have a solution, who are addressing the problem. Certainly, Senator Inhofe was not addressing the problem. But he came from Oklahoma, so you have to look at what politicians are saying, what they offer as a solution, whether they deny that there's any problem, which often they still do, and so on. So I would just say to you, and I'm not just talking about politicians at the federal level, but at the state level, at the local level, at the school board level, every level. Anytime there's an election, you certainly must vote. You certainly must think about the people who are going to do the right thing and maybe contribute, support them financially if necessary, and beat up your kids to make sure, and grandkids to make sure they vote too, because often they don't.
If I could just follow up, yeah, obviously, no one, you can't tell us how to live, but in order to vote for politicians that will actually successfully meet the challenge, then one has to have an idea of, what kind of things one wants a politician to support. And that's behind my question of, do you see, what do you see as necessary changes in our consumption, and what policy directives do you see needed in order to make these changes? What do you see as what we should be supporting through our vote?
Well, there are two sides to that, I suppose. One would be to vote for an an increase in the availability of renewable energy. And the biggest example of that is offshore wind up and down the east coast of the Gulf of Mexico, which is currently suffering because of the lack of finance and also regulations. So politicians who are willing to address the regulatory constraints on offshore wind, I think that's an important aspect of it. Similarly, there's a lot of solar that's being produced and wind energy that can't get to where it's needed because we have very outdated transmission lines. So that's another aspect of permitting and so on. On the consumption side, or I think the Inflation Reduction Act has gone a long way to addressing some of those issues. So requiring car manufacturers and appliance manufacturers to produce much more efficient ways of using appliances or driving. Those are essential components to this. We just talked about transportation. The car industries for years have resisted raising the miles per gallon that a car would get. You think about that. I used to have a Volvo before an old Volvo, 20-year-old Volvo. I was getting 28 miles to the gallon in my old Volvo. You go to the car companies today, buy a new car, you might get 35. That's like 30 years on from when I had my Volvo. Now imagine you go and buy a computer today, would you want a computer that was not much more efficient than it was 30 years ago? No. Obviously, the efficiencies are there, but the car companies are not willing to invest in producing cars. They have to be mandated to do that. That's what the Obama administration tried to do that. Trump administration rolled that back. So you have to look at what these politicians are willing to step up and do in order to reduce consumption, make things more efficient, and allow the development of renewable infrastructure. The infrastructure plan has gone a long way towards that, actually. Okay.
I just want to say one thing.
Yeah.
It's important to vote, but your Congress people will not know how you feel about things unless you contact them and demand that they listen to us.
Yes, that's true.
Voting is not enough. Contact them. Be in constant contact.
Yeah, that's true. You have to be able to engage there in a conversation. I agree with that. Thank you very much.
I just wanted you to know that we are going to put this talk on